Well, hello, and welcome to Apologetics 101. I'm here today with my guest, Dr. Timothy Clarey of, I believe it's Institute for Creation Research. Is that right?
That's correct. It's a pleasure to
That's
be
all.
here.
Thank you. I appreciate it. For the first time on this channel, actually, appreciate you actually wrote a book a while back called Carved
Mhm.
in Stone. It's become very famous among a lot of YCs.
Mhm.
It's actually it's actually a pretty heavy book. It feels like it's made out
Mhm.
of stone.
Well,
I guess that's the
I always tell
appearance.
people it holds the door open in a windstorm pretty well.
Right. Um, all right. I usually start off with asking you to present a introduction. Your
Okay.
background. I know that
Mhm.
I know you journeyed all over the world with a major oil company. That's going to come into handy in this discussion.
Mhm.
So go
Mhm.
ahead, just kind of give a introduction of yourself and your background.
Okay, I actually have a PhD in geology from Western Michigan University. Before that, I actually worked in oil and gas with Chevron Oil Company. So I got a master's in geology at the University of Wyoming after getting my bachelor's. And then I hired in Denver when there was some still pretty good, plentiful oil and gas company jobs. And so the early 80s, I was hired on. And then immediately kind of things tanked, but I was able to stay with Chevron for almost 9 years, over about 8.5 years. But in that time, I bounced around quite a bit. I worked mostly exploration. I worked the onshore areas in the United States, and I worked the offshore areas in the Gulf of Mexico, which now is the Gulf of America. And I also worked a lot of the middle part of the continent as well. I did some development work. I sat wells, went through the pay zones, all the things a petroleum geologist does, including finding oil. But it was a great career. I didn't get to travel the world so much other than a few conferences I went overseas on. But the data I've been gathering since I joined ICR 12 years ago now, after teaching for 17 years after getting my PhD, I actually taught a lot of college for many, many years full time. I still do some part time teaching for Liberty University and another local university here in the Dallas area. But I joined ICR full time and I've been gathering and compiling oil well data. And so if I didn't have the background oil well, research and working, making cross sections, looking at seismic data, analyzing the wells, looking for which zones to drill into. I don't think I'd be able to do this research that I'm doing. So this has been I've gotten through now 6 continents. That book covers 3 continents. Carved in Stone covers the first three, but it really sets the stage, sets the pattern for what I saw for the other three. So since then, I finished Asia, Europe, and Australia in that region. And I've actually just finished compiling what data there is around Antarctica, but it's not in the database quite yet. So I'm actually going to have 7 continents worth of data, what we know, what's still there today, what sedimentary rocks, what some of the volcanic rocks, what's all there today. And to me, it really shows evidence of a global flood. But without my background in oil and gas, I don't think I could have done this research at all. That's I believe is the Lord's hand in preparing me for what I'm doing at this point in my career.
Absolutely. And your book here, right here, Carved in Stone. It's become very famous. I think just about every young Earth creationist has your book at this point. Um, I would like to read something that's going to be, it's kind of very relevant to what we're discussing today. It's from your book. I figure I just saw it a few minutes ago, so I'm just going to kind of just read this real quick. And
Okay.
I think this is kind of an awesome statement. He says, you said often secular geologists insist that most organic oils were generated millions of years ago, even 150 million years ago, and have been preserved and trapped under great pressure ever since. This is a false assumption that is almost never thought through logically. If Earth were truly that old, the oils would have been destroyed by bacterial action, and the geologic pressures would have long since dissipated. We know that oil at the surface is quickly consumed by bacterial action, literally eaten, like in the 2010 Deepwater Horizon oil spill in the Gulf of Mexico. We also know that bacteria live in virtually every environment on Earth, even at great depths in the ground. So it is reasonable to assume any oil beyond a few thousand years old would be totally degraded or consumed by bacterial by now. The oil simply can't be millions of years old. Organic compounds cannot last millions of years in any natural environment. Thus, there shouldn't be any ancient oil anywhere. I thought that was pretty cool. That
Yes.
basically that this bacterial that actually live or exist in oil, and that they would have already eaten the
Mm-hmm.
oil by that point. But
And most of the oil that most of the oil produced today is partially or pretty heavily biodegraded. Actually, there's very little oil that's not biodegraded to some extent. But go ahead, you were
right.
going to ask me a question.
Well, I was going to say that in case anyone doesn't figure out yet, we're going to be talking about oil today. We're going to be talking about the fact that well, there's a particular objection that's usually made about the oil industry, but we'll get into that. And obviously, we're going to be it's going to be in relation to the age of the Earth. Um, and
Mhm.
I'm gonna go ahead and get into my first question. Dr. Clarey, before we jump into the
Okay.
details, could you briefly share your background in petroleum geology? You already did that some degree, and how your
Mhm.
years in
To
the
some
oil
extent.
industry shaped your perspective on how companies actually find hydrocarbons. So
Mhm.
basically, I think you did mention this in your introduction that you think that this was a blessing, a benefit that actually
Mhm.
has helped you in your current profession, current research into this matter.
Mhm. Mhm. Yeah, and to find oil, I mean, it's there's a couple basic things to it. It's you need to have a some sort of a trap to trap the flow of the the oil droplets as they're being moved by groundwater, presumably. And you also need a seal to kind of seal it from leaking all the way to the surface. We see a lot of oil seeping out to the surface. That's the original oil seeps where they drilled oil seeps first to find oil because they knew there was something coming out of the ground there. And so that's it. Even offshore, there's still a lot of oil seeping up to the surface. It tries to find a way to get out of there and get away from the high pressure. But another reason why it gets eaten up, but there's a lot of bacteria, even as deep, they measured recently, a couple of years ago. There's bacteria all the way down as far as we've drilled, down over 3.1 miles down, they still find bacteria. So the bacteria underground is a little slower acting, doesn't have all the oxygen we have at the surface, but it does biodegrade a lot of the oil. And but the basic idea behind finding oil is the same game in terms of you need to find a trap. A lot of times it's a structural trap where you want to find like an anticline, which is like a upside down cereal bowl that can trap the flow of those little droplets of water. So you need like a source rock, something that's rich in organic material. These black shales usually we think of as source rocks, and they usually seem to be. And then you have to have the right organics in there to produce the oil. And then secondly, that oil has to migrate to some sort of a trap. It has to have a reservoir, we call it a sort of a porous material to collect the oil, like normally a sandstone, sometimes a limestone that has openings in it. And then you have to have a seal on the top. It doesn't let it all escape. And so the basic idea behind that is pretty simple. You just need the source rock buried deep enough in the earth between about 8,000 and 15,000 feet down to get the heat of the earth to kind of cook the oil out. And they've actually found in the laboratories they can actually produce marine algae into oil in under an hour. So under the right conditions, you can do it really, really quickly. It doesn't take a long time to form oil, but we don't know really what happens underground. Most oil and gas geologists just kind of say what they've always heard in school. They'll say the oil in Wyoming, for example, was 150 million years old and migrated out there to just sitting there waiting for us to produce. But logically, they don't think that through, as I said in what you read, because that oil can't just sit there for millions and millions of years. There's always groundwater flow. And I went back for my PhD at Western Michigan and I studied groundwater flow, which I never really knew enough about when I was in the oil and gas business. But there's constant groundwater flow everywhere. It's constantly bringing in, the idea. I looked up the research and the evolutionary geologists think, well, the oil was kind of pasteurized at some point. It hit a temperature of 80 degrees Celsius, 100 degrees Celsius would be boiling, but it hits this magic pasteurization temperature and it kind of seals it off. Well, there's nothing sealed. That's why we can't dispose of our hazardous waste, our liquid hazardous waste, all these, nuclear waste. There's nothing that really seals off in the natural world. Everything leaks and our landfills leak, we have to compensate for that. And there's all sorts of wells, whole industry trying to clean up all of our contamination we've done because everything leaks. But even underground, even if they were pasteurized for a few years, you're going to immediately start bringing in more water is going to be coming in contact with that oil. and you're going to be bringing in bacteria and all along. So there's no place to seal it off, and so there's no feasible logical way you can argue that the oil remains pasteurized for millions and millions of years. I'm talking 150 million years. And so to me, they were taught that. Everybody's taught this stuff. They're taught about these millions of years. And you go to school in geology, you're taught millions of years and billions of years, and everybody has that in their head. But you really don't need that much time. Oil can form quickly, as I mentioned, in the laboratories, but I believe oil can form within just a few hundred years. The Bible talks about oil seeping up after the Tower of Babel, after the flood. I think you buried all this organic debris during the flood year. And then within a couple hundred years, during the time of the Tower of Babel, which is 100 to 300 years after the flood, based on the age of Peleg, you would have oil already coming out of the surface. And so it doesn't take that long to form. But the key thing is it can't survive in the ground for millions and millions of years.
Right. Um, there was a question that popped in my head. I was wondering, does any oil
Nor
form during the flood, or how, I mean, from a YC perspective, how does the oil form exactly, in contrast to how maybe evolutionists believe it formed?
Well, I think it's a matter of it's the timing of a lot of it. I think oil. I would say that there was no oil as we know it pre-flood, because you have to bury a lot of organic debris. You have to make these source rocks, these black shales that they call them, that are 5-10% total organic carbon. You need to bury stuff fast enough to preserve those, because things that die today at the bottom of the ocean, they settle down and they get eaten by the things. You don't build up layers of organic uh, I guess, rich in organic layers of rich in organic material that isn't reconsumed by something else. So to preserve these things, the evolutionary community has to say, well, these were anoxic environments where there was low oxygen, like the bottom of the Black Sea, but a lot of these were open ocean areas. And so there's a bit of a problem to explain how you get all these black source rocks that are so rich in these plankton and algae, which is really what the main two organic compounds are that make oil, marine algae and marine plankton. You bury those fast enough during the year of the flood, you can preserve a lot of organic material. And as that's buried deep enough in the earth, it cooks it out. And the mystery still is, how does it get from the source rock to the trap, to the reservoir? Nobody really understands that, because it's hard you can't go in the earth and see, but we see the results that it did. But our view of the oil versus the traditional, so the younger view versus the older view, is that it doesn't take that long. And the argument is it can't sit around that long either, so it can't be that old. It doesn't take that long to form. But it all formed, I think, as a consequence of the flood. You get your source rocks, and you build your piles of sedimentary rocks, where most of them were formed in the flood year, and you bury your organic material. Those organics get cooked, the little droplets get percolated out, they get trapped in a reservoir by some sort of a seal over the top, and then geologists can drill into that and tap the oil. Basically, it's almost like you know open up a you know, and many of them are under high pressure. What you read earlier, I'm talking about overpressured zones. There's a normal pressure as you go deeper in the earth, but there's a lot of zones in the Gulf of Mexico or Gulf of America. All these different
Right.
places in the world, you get these overpressured zones, which causes those blowouts, like the BP well did. Well, if those are really buried millions of years ago, that pressure should have dissipated down to the normal, pressure of just going deeper in the earth. We shouldn't have these locked in zones. Again, everything leaks. Everything leaks all the time. People need to study
Right.
groundwater geology, and they'll realize that everything's being moving all the time. There's minerals and rocks flowing with the dissolved in the water. That's one of the problems they have with radiometric dating, is they don't know what was originally there and what wasn't. They forget that there's groundwater flow all the time, everywhere, pretty much. Some places faster than others, but it averages about 50 feet per year. So you get groundwater flow flushing things out, moving everything around, including bacteria.
Right. And of course, today we are discussing, we're going to be maybe a little bit into radiometric dating. I
Mhm.
had a wonderful end of review. Uh, I don't know if it was this year or I can't remember. It might have been last year, might about the end of last year maybe.
Okay.
I had a wonderful interview with Dr. Andrew Snelling on radiometric dating. That was
Oh yeah,
incredible.
yeah. He's a good friend of mine. Yeah,
Awesome.
he's really studied that in more detail than me. He never worked in oil and gas, but he worked in the minerals industry and things like that, I
Right.
believe. But
And he was on the
he's
Ray
really an
Project.
expert on that. Yeah. Hmm.
Um, all right. My next question is, critics often say that oil companies require radiometric dating to locate hydrocarbons, claiming the industry wouldn't function without accurate deep time dates. From your experience in the field, what actual data do petroleum geologists rely on when determining where to drill? What are their methods? What are the methods that they use to actually
Mhm.
find and drill
Mhm.
for oil? My understanding, they do use a lot of different methods.
Well, they do, but it's mostly the traditional things where, and I've argued in I think in that book in a different chapter in the Carbon and Stone book on your, you it really doesn't matter how old you think the Earth is. It's a matter of whether those materials are still there. And so I think that the best chance of them being there is that they're young. But if you're looking for coal, if you're looking for minerals, any sort of practical side of geology, looking for oil, you know, it you can argue it's 4 million years old or 4,000 years old. But to me, most of these things can't last that long. But to the aggregate practical side, it really doesn't matter how old the stuff is. It's just a matter of whether it's there or not. And I think because it's young, you have your best chance of actually being there. If it was really old, it would have been eaten and biodegraded away. But the main thing about finding oil is you use a lot of seismic data, use a lot of oil wells that were drilled in the past. That's kind of where you start, and then you start connecting those wells with seismic offshore. It's really cheap compared to onshore to shoot seismic. They've got lots of seismic data. You don't drill a well now without seismic data. So you really need to get these seismic reflectors that reflect off the different changes in density as you go down in the earth, and they have to do some velocity models on some of those wells. They kind of estimate how fast the rocks are, so to speak, how fast should sound waves go through, and they can estimate and get actual real time seismic if they have the right velocity models. But a lot of times they're just images reflectors, and so they're not always in the right, true depth where they should be unless you have a good velocity model. And so sometimes we make mistakes with the seismic. We think there's a big anticline there, those upside down bowls that might trap oil, and it's really flat because of some velocity issues and things. So, but you don't drill any wells without seismic. And seismic today is so good offshore that you can sometimes almost see the oil, what they used to call bright spots, where you can see it because the rocks offshore are not as solid a rock; they're more just packed down sediments. And so when you shoot seismic out there and you see these really big reflectors, it's telling you there's a big difference in the rocks and the fluids that are there as well. And so there's a difference in density that shows up sometimes. So it's
Right.
it's less likely to miss offshore in some of these things than they used to be onshore. Onshore, you can't really do that. So you rely on mostly wells that were drilled, and then whether they hit or they didn't, that gives you data points. Rely on the surface geology. They used to look for anticlines at the surface, but those have mostly been all drilled up, these big bowls. And so but mostly it's seismic and well control that tells you where to drill a well. And again, you can argue and say they're millions of years old. I would say they're 4,000 years old. Most of these structures and features from the flood, maybe 4,500 years old. But the game is the same. I can find oil thinking these rocks are young. The old Earth guys can find oil thinking the rocks are old. I think they're wrong, but it's the same process. Looking for anticlines, looking for the right reservoir, looking for the right size feature. These big anticlines that trap the oil. As long as you have some sort of a sand or something that's porous to trap the oil, you have to have a source rock nearby that was buried deep enough. Some places, the rocks are too shallow to actually generate the oil. But if you get a place that's buried about 8,000 to 15,000 feet down or so, you can generate the oil from a source rock. The source rocks have to be rich in organics, which I believe are best explained by burial of these marine plankton and algae during the flood year. That's why they're there as well. But the game is the same, whether you want to believe it's young or old. And that's
Right.
why people that are old Earth can still find oil because you're looking for the trap, the reservoir, the seal, and the source rock. And if you have those four things, you're going to have a better chance of finding oil.
Right. That was actually my next question as well. So you answered that. So
Okay.
basically what you're saying is
Sorry.
that no, you're fine, man. It makes things go a little bit easier and smoother when you kind of answer multiple questions at the same time. All right. But you're saying that they don't need radiometric data. It doesn't matter what you believe on the age of the earth when you're looking for oil. You have those
Right. It's all
four things that you
relative.
mentioned. Go ahead.
Yeah. And it's all relative. Like I know one of your questions, you kind of gave me the questions ahead of time. That may be why I'm answering some, but some of these are very interrelated. But it's really all relative. Do you have the right layers and the right, in order? Do you have the right forming? Did your trap form at the right time before you started generating the oil? All these little factors. To me, I found oil and I believed the earth was young. I used to talk to some of my colleagues once they knew I was a pretty good geologist. They knew I wasn't just some Yahoo. I was able to find oil and do well workovers. We found a new pay in a field up in North Dakota one time because I was looking at the well logs and analyzing the well logs. And so it's the same process to find oil, whether you believe it's old or young. Again, to me, it just bothers me that people can say this oil's been sitting there for, 10 million years, 150 million years, just waiting for us to drill into it. It's like, do you hear yourself? If you understood groundwater flow, there's no way these oils can be that old and be stuck in the ground. You take gasoline and put it in your shed for 20 years in the back of your house, and then try to pour it in your, lawnmower and see how well it works. I mean, that's at the
When I was
surface, but that's even sealed up in the gas tank.
When I was talking to a critic about this, the critic said, "I brought you up because you have been with a major oil company
Mhm.
for, like you said, years." And
Mhm.
he said, "Well, while he's with that oil company, he probably had to use secular methods to find oil." And I'm like, or the method, the assumed deep time assumptions and things
Mhm.
like that. And I'm like, no,
Yeah.
you could be a young Earth creationist and still find
Mhm.
oil.
Mhm.
So it doesn't
Yeah,
matter whether. Go ahead.
no, man, that's exactly it. It's those four things. If you have the seal, the reservoir, the trap, whether it's a fault or a stratigraphic trap, there's different types of traps, but you got to somehow get the material so the oil can't all escape. And then you got to have a source rock. And it doesn't matter if you think it's millions of years old or not. And the bottom line is there oil there once you drill? All those things seem. I did this in Texas one time. We had everything seemed good, and we drilled into it and we got no oil. And so sometimes you never know. But in that case, I don't know exactly what we never did figure out exactly why it didn't have any oil. It might have leaked away earlier. It might have been enough fractures in it that the oil was able to escape. But sometimes everything looks good, you drill it, and there's just nothing there.
Right.
But that's not the case every time. I mean, oil is it's the same way. And, sometimes I miss that. To find that they shoot some new seismic, and you get to find these new features that have never been drilled, and you get to make sure that there's some sort of a reservoir and some sort of the easiest way to find oil is an area that's already had oil nearby. The oily basin we call it, like the Bighorn Basin in Wyoming has been, that's the oiliest basin we call it in Wyoming. It's found more oil there than any other little individual area. The Gulf of Mexico or Gulf of America that's loaded with oil. It's got the right traps with the salt domes and all these different things. But I believe all those things happen quickly, and we're just seeing the results of very rapid deposition during the flood year, which preserved all the organics, and there's the sands and the things that the oil gets trapped in. All that can form very very quickly, and you'll still get the oil. So there's no difference. I know one of your questions is going to get into this basin modeling process. I've had
Yeah.
critics complain about that before.
Uh,
Doesn't
Let me go ahead
basin
and ask
modeling
that one.
take millions of years? We'll get to that later. I'll save that one for later.
Well, yeah, that's
But
my
it really
actually my next
doesn't. You just
question.
okay. Okay.
Uh,
Well, people argue that I've heard critics complain about that, but go ahead and ask the question, and we'll
Yeah,
try to answer that.
that's another thing I was going to say. That this is an important question for our topic today because a lot of critics bring this up because they think that Bayesian modeling does that. Some argue that Bayesian modeling software requires radiometric ages to predict maturation windows. In real-world
Mhm.
exploration geology, how much
Mhm.
of Bayesian modeling depends on assumed
Mhm.
absolute ages versus measured physical parameters like pressure, depth, temperature, and source
Mhm.
rock characteristics.
Mhm. Well, again, the basin modeling program has got the millions of years built in. So of course, along the bottom, it's going to have the millions of years, but that isn't really how you find oil. That just kind of makes the managers feel better. They're like, oh look, we're in the oil window. It's been in the oil window for us, so long. The key thing is they don't realize, and this just came out in the last 20 years or less, actually less than that, that oil can form quickly, and so nobody really knew that. I have a dry voice, but
That's fine.
if you get rid of the stigma that oil takes a long time to form, then you don't need the millions of years. You just got to bury it deep enough, let the earth cook it out. It might take a few hundred years, maybe a few thousand years at most. But again, they also don't think about how it's going to be biodegraded. And so the whole thing is built into the system. They already put the millions of years down there. All you have to do is replace the millions of years with thousands of years. And most of it actually happened 4,500 years ago during the flood. Most of the structures we see, most of that form the traps, most of the sedimentation happening, most of the organic shale, the source rocks being deposited, all that happened all at once about 4,500 years ago. If you believe what the Bible says, if you believe that, in the young earth, the evidence for that. And I do. And that's why you just got to replace the numbers on the bottom and everything and squeeze it all together back to about 4,500 years ago and then see where you're at. The sediment thicknesses are the same. You can call them Jurassic, call them whatever you want to call them, but the sediment's still there. The trap's still there. Whether it got cooked by the earth or not is still there. And you know that by, drilling wells. If you hit oil, obviously there had to be a source rock that was in the oil window, they call it, between about 8,000 and 15,000 feet down. If you go deeper than that, you get a lot of natural gas. So sometimes there's wells that go down 20,000 feet. You're getting, like in Mobile Bay, Alabama, you're getting really deep gas wells. But the liquid oil, which is the real moneymaker when I was in the business, that's a little bit, between about 8,000 and 15,000. But
Uh,
the whole idea is they build the numbers into the system and they insist they have to have that. But that's not how oil forms. Because oil can form quick. And we never really use that to find oil. We use seismic and wells. Seismic and wells, we made maps. We correlated our seismic, to the wells. Then you find your reservoirs by the wells. You see what's a potential trap based on the seismic, and you have your source rock in the area because there's other oil found in the area. There's oil all over the Gulf of Mexico or Gulf of America. There's oil all over certain basins. If you're going to a brand new area, for example, say in the Arctic Ocean, a new basin up there, where you have no idea what's going on, you drill an exploratory well, but then you really analyze. You'll take cores, and you'll pick out, see what the rocks are really like down there, which
right.
you don't normally do. Once you've drilled an area, you can kind of figure it out. But the basin mod, to say you need the deep time to do basin modeling is rather, I think it's rather ludicrous. You don't have to have millions of years because oil doesn't take millions of years. But they build that into their system and they say, well, you have to. Like, you don't have to define oil. And it's just
So what
everything gets
is the
squeezed back 45.
so what exactly is the
Go
program
ahead.
used for exactly? I don't understand the concept of
Well,
what they doing with it.
well, it kind of shows as the sediments are being deposited. Of course, they assume millions of years for that, like the Jurassic was 150 million years ago to about 200 million years ago or so. So they put all that in. They show the thicknesses of sediment being deposited and how you build more sediment on top. So you get deep enough, and eventually it gets down deep enough into that oil window. Then they kind of show the colors of where, okay, during this time you could generate oil. And then so you're deep enough. It really shows, is this area deep enough to generate oil? And you can know that by the thickness of the sediments there. You don't, the data comes from the wells that they've drilled into, and they can kind of stack the different things. Then they assume deep time for all their different layers. So they stack them on there, but the thicknesses are still the same on the side. It's just the time at the bottom when they were being deposited. Sometimes it shows the erosion. There's a lot of erosion, I believe, in the receding phase of the flood. So you'll strip some sediments off the top that might have already been buried deep enough at one point, and then we're now raised up a little bit because of erosion. So it kind of keeps track of all that, but it's all built into the deep time paradigm where they insist that these things are, this happened so many tens of million years ago or hundreds of million years ago. You deposit things, but it's an interesting program. But again, the time is hocus pocus, in my opinion. That there's no way to go back and say these things really happened so many millions of years ago.
Could
But
you
it does show
factor
the
in
thickness of sediments.
could you factor in
Pardon
young
me?
Earth well, I was going to say, can you factor in young Earth parameters into the program and would it come out with the same thing?
But I think you could. I don't think anybody's done that. You could put in the time, of these things, and basically they'd all be on top of each other. They'd all be within, the 100, 200, 150 days of the, well, maybe 300 and some days of the flood between the receding phase and the rising phase. You'd have to pack it all in there 4,500 years ago and then expand that. And I think you get you'd show that these sediments are still there. The sediments are the same, whether you believe they're young or old, the thicknesses are still there. All that would work the same. But I don't think the program would allow you to do that without going back and reprogramming it a little bit. But
So
You can show that these things are still in the oil window because they're buried by all these thousands of feet of sediment above it. And so it
But you
just
would
when
say
did that
that,
sediment get down there? I think that,
right? So
the,
you would
the
say that,
thicknesses of the sediments are still there. Those are real. That's what I was able
right.
to use the oil wells all around the world, thousands of columns to, study each continent. And part of it's in the carbon stone book. But that data tells you the thickness of the sediments. And so you use that in conjunction with, they put in the millions of years when they think they're deposited. But if you were to do it as a young Earth time frame, you'd get the same results, I would predict. It's
So
just a
you
matter of
say
I don't
that,
think anybody's done that.
right. So you would say that it's assumption based, the program
Mhm.
itself. So it just depends on
Right, they
which
built
assumptions you
right.
apply.
They build the deep time into the whole system, but the sediments are the same, the thicknesses are the same, the depth below the earth would be the same, so you could still generate the oil the same. That's the
Right.
bottom line.
Right. Many people understand the industry's dependency on relative stratigraphy rather than absolute chronology. Would you explain how
Mhm.
lithology, structural mapping, and sequence stratigraphy guide exploration independently of radiometric dates?
Okay, you mean sequence stratigraphy and all that stuff, relative stratigraphy and absolute chronology, and again that goes back to almost to the basin mod. They assume that all these rocks are tens of millions of years old or hundreds of millions of years old. They assume all that based on their age dates, which is, you talked to Daniel Snelling about the assumptions built into those. But they really, when you're looking for oil and things and coal and looking for coal seams or whatever you're looking for, you do use a lot of seismic. You'll drill through things and make sure and that makes the seismic kind of real because you're able to tie the seismic of a well over here, shoot seismic through that well, and you're able to extend those rock units out in a greater direction. Then you can look for the traps and you kind of assume that
Right.
about the same. But that's kind of what sequence photography is. You look for sequences. Sequences are very important. They're big pulses of sediment that came in a flooding event. There's a lot of smaller flooding events during the play that took place even during the Great Flood. There are six major sequences, which we now call mega sequences, but there's all these, thousands of smaller sequences as well. And the
Let's talk
first
about those.
kind of advance, yeah, the first advance of water across the land often will bring in a sandstone. And sandstones are important because they're often the reservoirs for oil. And so a lot of oil and gas geologists, myself included, we chased around these bottom of sequence boundaries. These kind of where the sediments first came in or crossed maybe on top of other sediments, not necessarily like the basement even, but across other sediments. So you could still map that out whether you believe it's young Earth or old Earth. I think it happened 4,500 years ago. This is all part of the flood making these sequences. Other people believe, of course, these are millions and millions of years in between each sequence. But to me, sequence stratigraphy is no different if you're young Earth or old Earth. It's showing you the rocks that are there in place. And the
Right.
lithologies are determined by the wells that are drilled, so you know what those little reflectors are showing. So uh, again, the game's the same. I was able to find oil. I didn't believe the Earth was millions of years old, but even when I worked in the industry, there was no laboratory. Our government laboratory had made oil in less than an hour from marine algae, and so now we have even more evidence that oil doesn't take millions of years to form. Once you get it down that oil window, now deep enough in the earth where it cooks, it's going to form oil really quick. And so oil does not take millions of years. You don't have to sit there in the oil and gas window, like these basin mod programs sit there for millions of years, cooking the oil out. Take, for example, the Permian Basin, which is out in West Texas by Midland, Texas. That's got one of the most oil almost in the country. That whole area, just anywhere you drill, they frack now. They frack into the source rock. They frack into the shale. When I worked in industry, we just drilled through the shales. We didn't have a way to go horizontal for miles like they do now. They go down a mile and they go out a mile horizontally and they stay within, a few feet of where they want to be. They're amazing technology now. And so they drill into these fractures and most of them are vertical. So they go about a mile hitting up a bunch of fractures. And then when they open up that zone, those fractures kind of ooze the oil in over that mile of horizontal well, it's staying in that, sediment or staying in that shale, and the oil leaks into that pipe. And so that's why they go for a mile to hit enough fractures. Well, if
If
that
I was
rock, if you do your basin modeling and you model that with the millions of years, that oil all should have been produced 200 million years ago or more. So why is there still oil there? Why is there still oil when we frack these things? when it should have been produced millions of years ago based on the basin modeling. They go back and you see, okay, the oil and gas window 200 million years ago. So why is it still there?
Right.
I
If I was
challenge
drilling
the
for
old,
oil, I would
old,
probably. I was gonna
unless
say
there's
if I was
more oil still forming.
right.
Oh, go ahead.
If
Sorry,
I,
Brian.
it's all right. There might be some delay on our on our window, but
I think it just does.
yeah, right. But if I was sitting there drilling for oil, that's probably where I would live. I'd live right
Well,
out
yeah.
there just getting the oil.
If if you own the land out there, you got to have the land. You got to have the leases. Basically, you really have to lease it up. But they used to just have certain size fields, and now they realize almost anywhere you drill out there, because you can go horizontally and then go, you got to stay under your lease. But you can now hit all this oil that we never knew we could get at. We doubled our oil and gas basically overnight by fracking, and so that's why the environmentalists are so up in arms about it, because they don't want to use oil. They want us to go back to the Stone Age, apparently. But oil they think is bad, causing climate change and everything else. But really, oil's not that bad. And even some people looked into it. Like Elon Musk says, if we stop using oil, we'll collapse into the Stone Age. We really would, because we get about 80% of our energy today from oil and gas, either oil and natural gas or coal. If you add all those so-called fossil fuels together, that's why we're able to do this broadcast. We have electricity. You charge your
Right,
electric cars. Most of that electricity comes from a coal plant. It's if you're arguing about what's green and what's not, and that's a whole other matter. So I don't want to
right.
get into that too much, but
Yeah,
it
yeah.
is important
Let's
because the oil and gas industry gets a bad rap, but
right.
that's
Let's go ahead and move forward. When you
okay.
worked in the oil industry, what specific data sets, such as seismic reflection, profiles, well
Mhm.
logs, did you get into this already? I think you might have.
A little bit. We covered some of this because some of your questions do a little bit of redundancy, which is okay because we want to make sure we cover it all. But that's what you use. You're mostly you could. Well, I didn't cover the thermal maturity. You can actually get samples from cores. You can take deep down in the earth. You can send them off to laboratories. They can grind them up and they can do total organic carbon, how much organics are there. They can see the maturity of it by looking at certain colors like vitrinite reflectance, things you don't need to know about. But you can kind of see how dark the organic material gets. And the darker it is, of course, the more it was cooked. And so there's a level where if you're going to generate oil, you have to be a certain color. That means you're very deep enough into the oil and gas window. And so this supersedes any basin modeling. Basin modeling is all just kind of like, oh, it's after the fact. This is
Right,
really how you find oil. If you drill wells, take cores, send the samples off to see if there's enough organics in there to generate oil. And, in that basin, for example, that low area that may trap a lot of oil. And it's mostly done by geochemistry. And that's how you determine whether these wells are in the oil and gas window, has the oil matured. But again, if it's matured millions of years ago, why is there still oil in many of these places?
right.
That's one thing they never seem to answer. But that's one thing they do. You mentioned that about thermal maturity indicators. Those are actually very, very important. But again, oil and gas industry relies on oil wells that were drilled, number one, and seismic, number two, particularly offshore where it's easier to shoot seismic. You don't have to permit across the land, and people like to have to pay money to shoot
Right.
seismic across your land, that sort of thing. And so there's not as much seismic onshore. And sometimes the seismic, the technology gets better and better as well as you can image better in the earth. But that's really how it's done. And then as long as you have these thermal indicators based on some cores that you took, maybe as you're drilling through the rock, you can core and see, are we in the oil generating zone? Are these the right colors to indicate thermal maturity for these little
Right.
microfossils and things? So you don't really need
Um,
basin modeling. Basin modeling it's just for the managers mostly to show them, look, we're in the oil window. It's like, okay, we're good. Let's drill
right.
then.
Um, we already did the number 7, so I'm gonna go ahead and skip that because
Okay.
we already talked about you talked about barrel depth and temperature history and that sort of thing.
Mhm.
Um, okay, on number 8, from a flood model perspective, how did oil form? I think we already talked about that too.
A
What's
little
the
bit,
difference
yeah.
between flood
You have to bury
model
organics.
perspective? Yeah, we're going to skip that one.
Yeah,
Trying to
vitreous
make sure
reflectance.
that we
Yeah,
smooth this
we
process.
just talked about. Yeah. Well, we didn't talk about the kerogen types in some ways. Some of the organics that are buried.
Do you want to discuss
It's
that?
mostly marine algae and plankton. Number nine on your questions.
Oh yeah,
A little
number
bit about
nine
the
for the next
kerogen
one.
type.
Can you explain how
Yeah.
Bertrand reflectance, petrolysis data, and kerogen type analysis are used to determine the oil window and whether these measurements depend on knowing um, a
Okay.
rock's radiometric age.
Yeah, they're independent of age. Whether the stuff's been cooked or not is just a matter of whether it's been in the oil window. And so the vitrinite reflectance, those are little microscopic organic debris, part of that kerogen they talk about, reaches certain colors, the higher temperature it reached. And so you can see what's in the oil window that way. Pyrolysis gives you the amount of total organic. Do you have enough organic material theoretically to generate enough oil that's sufficient for that area? And then the kerogen type really depends on whether it's oil prone or gas prone or there's type one, type two, and type three based on some geochemistry. You want one and two, that's marine algae and plankton. That's the best oil producing critters that got buried. The type three is more the woody material like coal. Coal can also produce some oils, but it's not as uh, good in terms of the marine algae and plankton. So the more we know about it, but again, none of this depends on age. It all depends on how deep they were buried.
All right,
There's a little bit of age involved. You can't just put it down there and pull it back up. There has to be, a few hundred years, I would may as a minimum. But you don't need millions of years. Oil can form quickly. That's what they don't. They don't teach you that in school. They don't
right,
teach you any of this stuff in school. They just teach you the millions and millions and million billions of years. So everybody comes out there going, they can't even think in their heads. And Andrew Snell and I've talked about this. It's so hard to get that out of your head because that's all you're taught. But oil doesn't take long to form. Oil can't last a long time in the ground because there's too much bacteria being moved by groundwater all the time, constantly. You can't just pasteurize it and then just stays there. Again, think about everything leaking. So super high pressure zones shouldn't be there either. They should have dissipated. It's just all sorts of issues they never talk about when you're taking geology classes in school.
all right.
And that's just
Basin,
something. Time is
right.
not
Okay.
required. No.
Basic modeling programs often include time steps measured in millions of years. Does this represent actual indispensable measurements, or are these merely conventional placeholders that don't impact the physical parameters companies care about, such as pressure, temperature, histories, and thermal gradients?
Yeah, we covered this a little bit earlier, but they don't really measure anything actual. You can't go back and get actual numbers to tell you that these rocks are 100 million years old. You get some age dates. They estimate from radiometric dating, but again, those are all based on several assumptions, and then they get an answer. And then if it fits the system, they're like, yeah, it works great. But they insist there's a deep time out there problem, but it doesn't really matter. The basin modeling program doesn't require millions of years because you get oil. You can do the same thing if you shorten that time frame. Take the scale at the bottom, you just put it in 4,500 years, and do most everything happened in 4,500 years ago or 4,000 years ago when the flood happened, all the deposition, all the burial. And then the way you determine whether it's been cooked enough is by, again, taking wells, coring those wells, checking out the shales that have the potential for source rocks and seeing if they meet the criteria for the vitrinite reflectance or the pyrolysis, giving you the organics. None of this depends on deep time. None of this, the practical side of geology, none of it depends on deep time. It's just a stigma that we've been putting out there because that's all we're taught. And so there's a lot of old earth geologists, friends of mine that have said, well, how do you do the basin modeling without deep time? You don't need it. It doesn't
Right.
doesn't really give you anything tangible. It doesn't help you at all. It's just a theoretical, and I keep saying it's for the managers, just to convince people, yeah, look, we're in the oil window. This happened. But if we're in the oil window, like in the Permian Basin in West Texas, 250 million years ago, why is there still oil there today? They should have all left. They should have all gotten away, and there should be drilling just dry holes out there, which
Right.
means there's no oil, just water.
I'm gonna skip question 11 because you've already answered that.
Okay.
Critics
Okay.
sometimes claim that if radiometric dating were wrong by orders of magnitude, the entire petroleum industry would collapse. From an insider's perspective, how accurate is this claim, and would you actually change in day-to-day reservoir prediction if deep time assumptions were altered?
Well, I think it would be a shock to most people in the industry because most everybody's taught the old Earth way in school. but it wouldn't make any difference at all if you went out there. If there was definitive proof, which we have some pretty good proof, you have all these, dinosaur original tissues we're finding, dinosaur bones, we're finding original proteins and worms that go back supposedly 500 million years, but they can't be that old or they would decayed away. Even oil can't be millions of years old because it would have decayed away. So all these things are telling you the Earth is young, yet they still just insist, oh no, it's got to be old, because that's what we're taught. And so it wouldn't collapse at all. You could still find oil, because you still shoot seismic, you still drill wells, you still check and see if there's, the rocks, where they be deep enough based on those indicators, again, the paralysis and the veteran reflectance. You still know if you're in the area that generated oil maybe a few thousand years ago and is still generating oil maybe today, drop by drop by drop by drop. Oil really moves on the backs of water, because groundwater is the real key to move everything around the subsurface and to bring the oil to these traps to get them there. But the idea of the trap, the seal, the reservoir, all that stuff is exactly the same whether you believe it's young or old. Nothing would collapse. It's just,
Right.
I don't know if that's scare tactics by the old Earth people or what, but nothing would collapse. You
Yeah.
still find the oil because the oil's there or it isn't.
I've heard a lot of critics would say that like the whole industry would go belly up if the radiometric dating wasn't reliable or that if the Earth wasn't billions of years old. But that's not true
Now
at
I'll
all,
start
is it?
going back. No, I'll go back and I'll start telling them drill here, drill here, drill here. It's the same process whether you insist the Earth is old, which I think is a mistake, or if it's young, like I believe it is. It's the same process. The oil be there or not. And when it came down to it, the management of those companies wouldn't care as long as you find an oil. But it
Right.
would just shock
Make
most
money.
people. What?
Right.
These rocks really are young? I'm like, that only makes sense because oil can't be old. Oil doesn't take
Right.
long to form.
Eh,
But it's there because it's young. It's there because it formed recently. But it wouldn't collapse at all. Just like
That's
coal industry wouldn't collapse if you said that
right.
coal is only 4,500 years old. You know, well, that's what I think it is. But you can say it's 50 million years old or 100 million years old. Uh, it, it's just a label you're putting on it.
Right.
It's still there or it isn't.
As someone who's both a professional geologist and a critic of deep time dating, what do you see as the biggest public misunderstanding about how hydrocarbons are found, generated, and accumulated? And where do you think the oil companies rely on radiometric dating myth comes from?
Well, if you work in oil and gas, you really don't worry about radiometric dates. You just throw those numbers out there because that's what you're taught in school. But nobody goes out there and goes, well, we better date these rocks, find out, if we can find oil. That never comes in the conversation. Again, you're looking for those four things all the time: a source rock, a seal, a reservoir, and a trap. That's really what you're looking for. And nobody talks about, how old are these rocks? They might throw them in there because they're taught that Jurassic rocks are a certain age and Cretaceous rocks are a certain age. But and I think going back to that, taking it to the next step further, is the public misunderstands that because they're constantly being told in movies and commercials, these are millions of years old. These are dinosaurs that died out 66 million years ago. These oil companies find oil that's millions of years old. And, they're constantly, even their press releases are saying the same sort of thing. And it comes down to that's what you're taught in the public schools. That's what's being taught in all the public schools. So that's all people know. But really, it is really just a myth of deep time. But nobody uses radiometric dating really to find oil. They
Right.
just worry about how thick the sediments are. Are you in the oil window or not? Were you in the oil window in the past? And then you have a trap and a seal and a reservoir. And so it's to say you need deep time to find oil to me is just ridiculous. It makes no
Right.
sense. But it's the public has a misunderstanding because that's all they're taught. That's all the
Right.
geologists are taught. There's only a few of us out there who realize, wait a minute, the Bible teaches a young earth. And then you start looking into the data, you realize oil can't be old. Oil can only be generated recently or it would decay away. And you find all those
Right.
original tissues of, like I said, dinosaurs and proteins, all that kind of stuff is telling you the earth is young, but yet they insist that the earth is still old. We just don't understand how these are preserved. Well, you got to tell me how billions and billions and billions of oil all over the world was preserved magically if you believe it's tens of millions of years old or more. To me, that's show me how the groundwater flow wouldn't affect and bring in new bacteria when it would. But nobody talks about that. They don't talk
When
about the evidence
right.
from groundwater flow. they kind of get away with it because they have the consensus is the sad part. And the public gets a misconception because that's what they show in the commercials. They used to tell you dinosaurs made oil. That's not true at all. Most oil
Right.
comes from marine algae and plankton that was buried rapidly, so it didn't decay away, and this so it can actually get cooked out as it got buried deeper in the earth.
Right. And my when I first came across this particular objection by the critics,
Mhm.
the idea was that they were
Mhm.
trying to say that this multi-billion-dollar industry is relying on the reliability of radiometric dating. So radiometric dating must be reliable because they're making billions of dollars of it by assuming that when they're approaching this topic matter. And a lot of people really don't realize that they don't actually need the Earth to be billions of years old to find oil.
Hey man, preach it, Brian. You don't.
Right.
You don't need it to be. You don't need it to be old to find the oil. The oil is going to be there. What again? It's whether you have those four components that took place. Did you have enough deep enough to generate the oil? When you go back even to those source rocks, how do those source rocks bury all that organics unless they were buried really, really fast in different conditions than what's forming today? The uniformitarian idea doesn't work to deposit those black shales that are so common all over the world at different layers. So you just got all these layers that are deposited all over the world, burying these things fast enough. And people think of shale and clay as being very, very slow, clay settling out of out of water. That's not the case at all. There's been studies by uh, well-known university professors with the flume experiments that have studied in the last 10, 20 years that these shales that we see that have thin layers in them called laminations, those only form when you have moving water. So even clays themselves need moving water about a foot or so per second because they flocculate. It means they collect together into bigger clumps and they settle out in moving water and they make these thin layers like we see in shales. So shales aren't just, you know, devoid of layers. They always have thin layers to them called laminations, very thin, you know, sub,
Right.
a couple millimeters thick type of thing. And so to do that, you have to have moving water, which is what
Right.
the flood gave
All right.
us. It's just a little slower maybe than the sandstones. But again, you got to bury these things fast, and the waters, of the flood allow you to bury these organics very, very fast. And there's enough organics in the world today. There's been a study back in the late 70s, being published, I think it's published in Nature. I'd have to look up the reference that shows there's enough biota, enough organics and carbon in the world today. If you buried everything in the ocean today, just one day, you buried it all, you'd have more than it's like 10 times more than any of the all the oil found in the world just in that marine algae in one day. So it's a tremendous amount of biota in the ocean today that could produce all the oil 10 times over of what we've actually found. And what's decayed away. Again, most oil is partially biodegraded or very heavily biodegraded. The tar sands, for example, in Alberta, heavily biodegraded. So they have to cook the
Right.
oil out of them. You don't get as good of, types of gasolines and components out of that type of oil as they do the more liquid oils and things like that. But biodegradation is a problem that does ruin the oil, and it's happening all the time. That's another reason
Right.
why oil can't be old. So anyway,
Many critics argue that radiometric dating provides an independent, objective constraint of the timing of sediment deposition and basin evolution. From your geological experience, how often do radiometric dates directly control stratigraphic interpretation
stratigraphic.
yeah,
It's a
in
tough one.
petroleum settings, and are there situations where radiometric dating or dates actually contradict lithogic or seismic contacts?
The answer to that is yes. There are dates that contradict it. There are. We've actually sent off samples in the rate project. We've sent off samples, and this happens a lot in the oil and gas industry, not the oil and gas, in geology in general, the academic world particularly. They'll send off samples and they'll publish papers and they'll say, well, these obviously can't be right because it says 300 million years old, and we know this is below rocks that are 500 million years old. So the data must be contaminated. So there's a lot of scatter in the data, and they have to pick the ones they think are right, ones that fit the system that they've already kind of preconceived. And so, but there's really no the timing of sediment and basin evolution, all these types of things together. It kind of goes back to the basin modeling, where they assume
Right.
deep time, so they kind of make it work with deep time. But again, you don't need any radiometric dating. You don't really need, you just need a lot of sediment. You need a lot of organic material buried fast and buried deep enough by more sediment to cook the oil out. And then the oil has to
Right.
have somewhere to, not to escape to the surface. It has to be trapped somewhere and then be in a zone of a rock like a sandstone that allows the oil to flow and the water to flow as well. So when you produce oil, oftentimes you get oil initially, and then you get oil mixed with water. And eventually
Right.
wells go dry, so to speak, because the oil gets separated. And that's why I try to go back in and flush it out with CO2, and they do some secondary water flushing and try to get more oil out of these. But traditionally, we leave about half the oil in the ground when we walk away from the oil field that we depleted. If it's, what we need is a better technology to get all the oil out of those zones. But
Right. This
there's
next
ways they're
question.
working on it.
Right.
Mhm.
This next question is a really
Mhm.
interesting one because I had a recent interview, like very recent,
Okay.
a live interview with Dr. John Baumgartner, who did the original
Mhm.
research on radiocarbon for the rate team, the rate project.
Mhm. Mhm.
Number 16, radiocarbon has repeatedly been detected in coal, oil, natural gas, and even diamonds at levels far
Mhm.
above AMS instrument backgrounds. From your perspective, what does the consistency of these measurements across independent labs imply about the source of that carbon 14?
I think it tells you their consistent age. That most of this stuff happened all at the same time because many of these will come up with, using today's carbon 14 ratios, which is not the right ratio in the past. But if you use today's ratios, they come up with about 40,000 years old. Many of these come up between 30, 40, 50,000 years old. Dinosaur bones they send in get the same thing. All these things go, coal, same thing, oil, the same thing. They're all showing measurable carbon 14 well above contamination levels, as you mentioned. Even in diamonds, how do you contaminate a diamond? All these things we sent off, I think 20 diamonds, Dr. John Baumgartner probably talked about. They're all sent out to these different labs. They didn't tell them what this stuff was, how old they're supposed to be. And all these labs came back and reported measurable carbon 14, showing that they're only about 40, 50,000 years old. Now, we don't believe that's the right age. That's just based on today's carbon 14 ratio in our atmosphere. In the past, if the ratio was a lot lower, which we believe it was, that would explain why 4,000 became 40,000. But it definitely doesn't tell you these are millions of years old because after 100,000 years, I think in here, that's the maximum you can measure because you run out of carbon 14 quickly. Every 5,730 years, you lose half. And so it keeps going down, down, down. I think carbon 14 is accurate for maybe a couple thousand years, fairly accurate. But then after that, you don't know what the ratio in the atmosphere is. And suddenly it jumps up in the ice age to 40,000 years old. And that's what we see in coal, oil, all these things that are old. No matter how old the coal is supposed to be, 300 million years old or 100 million years old, you get the same number. Why is that? Why do you get about the same approximate amount of carbon 14? Because they're approximately buried all at the same time during the flood 4,500 years ago. You might not get the right number because we don't know what the ratio in the atmosphere was in the past, but the consistency of all these compounds, there's coal, oil, dinosaur bones, different bones buried even deeper than dinosaurs. All these things all come back with the same approximate numbers, 30, 40,000 years old. How do you explain that? They just, the majority opinion just, oh, it's just contamination. But the consistency is there, and there hasn't been an adequate explanation of it. They just kind of ignore us. They ignore Dr. Baumgartner's research on runaway subduction and real fast plate movement. They ignore you when you're on the right track and they can't explain it. They just try to ignore you. So I get ignored a lot. Hugh Ross just
Right.
wrote a book on the global flood, and he doesn't even mention me in it. And it's like I've been doing this work now for 10 years. So you can at least say, well, Clarey found this, but they don't even address my work. They just kind of choose to ignore me because it's very difficult to explain the global patterns I'm seeing on every continent doing the same thing in the same order in the same rocks on every continent at the same time. And they all peak at the same time. That's what that book really shows is all the continents are showing the same pattern of rocks, same order of rocks, same order of fossils, and they're all doing it at the same time, which to me screams global, global, global. Something global happened, and I think the flood is the best explanation. If you
Right.
collapse deep time away, industries won't fall. People's brains will explode, and they'll realize maybe the Earth is young, but we can still find oil, we can still find coal, we can still find minerals, And so you don't have to believe the Earth is old and insist on all these techniques to make it old. They need the old and deep time only to have time for evolution. So it's like two pillars. You need evolution, you need deep time. You take one of those away, everything collapses. So it's going to be very difficult for the mainstream scientists to ever admit that the Earth could be young. But yet all the science is stacking up, showing more and more and more that it's young in these. Again, carbon 14 is one of them.
If the
The consistency. And
I've heard often that if the Earth was made of nothing but carbon 14 atoms, it'd be all gone before a million years is even there.
well, yeah, it'd be completely young. We couldn't measure if anything been 100,000 years that you can't measure it, so you'd get an answer of zero. You just get the instrument error, which is very, 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 very small. We're seeing much greater carbon 14 than with the instruments getting better and better. We're still seeing stuff way above industry error, and so it's difficult to explain it away. But again, since they have the microphone, so to speak, they have the majority opinion. It's like the emperor's new clothes. They can choose to ignore us as much as possible and claim
This
that we're pseudoscientists,
right.
we're this, we're that, just because we don't buy into the old, we don't
This
buy into the
next
old Earth paradigm.
This next question, you answered a little bit or hinted at. Critics insist these detections must be contamination either during sample
Mhm,
preparation or through an in
mhm, mhm,
situ neutron capture. But the rate team's diffusion, shielding, and background control arguments say otherwise. What do you see the strongest geologic or chemical reasons why contamination cannot easily explain radiocarbon showing up in deeply buried supposedly multi-million year old carbon sources?
mhm. Well, one of the things they try to argue is there's uranium nearby that's going to generate it, but they've done studies. There's been lots of papers published by chemists and physicists, including the rate project, that show that these factors aren't going to produce enough carbon 14. All the carbon 14 we're finding is way above the industry, the instrumentation error bars. And so it's not the instruments that are causing the error. That would be way too small, causing this carbon 14. The carbon 14 uh, does appear to be real. And again, the consistency of it argues for it. One other thing that you didn't maybe mention here is carbon 13 to me helps verify it. When they do carbon 14 dating, they also do stable isotope carbon 13 ratios as well. And the carbon 13 they're finding in dinosaur bones, for example, are indicating these dinosaurs ate certain types of plants. Some dinosaurs ate what's called C3 plants or C4 plants, and that affects the results. So if the results for carbon 13 haven't been contaminated and they're found in the same, at the same time, then how can you claim the carbon 14 is all contaminated, but the carbon 13 is still legitimate? And so I put forth that I have a dinosaur book that I have called Dinosaurs Marvels of God's Design, which is a pretty good book over here if I don't fall over hurt myself. I don't know if your viewers can see this or not, but this is
It looks
available
like
as
good.
well. Dinosaurs Marvels of God's Design. I'll have to send you a copy, Brian.
Oh,
And
thank
so
you. I
let
appreciate
me
it.
know and I'll get you. I'll send you a copy. But I talk about in there a carbon 14 found in dinosaur bones. And then the carbon 13 to me, though, is the numbers you should get exactly for those types of plants. An animal becomes what you eat. If you're eating plants that are C3, like corn and things like that, I believe, or C4 plants, it all depends on the carbon, how they're arranged in the particular plant. You can still see that in the carbon 13 ratios. And so
Right.
those are legitimate. They measure those carbon 13 to 12. So if
Here's
that's
a
legitimate, again, why would just the radioactive ones be illegitimate, so to speak, and be wrong? Why would they
here's
be
a
contaminated,
rel-
not the C13? So
right. Here's a related question. Some have suggested that
mhm,
subterranean neutron flux from radium
mhm,
thorium trace elements could generate
mhm,
C14 in
mhm,
situ. I think this has to do with background radiation, like maybe
mhm,
where the carbon 14 actually is. Maybe that some people
mhm,
suggest that background radiation could actually um, um, uh, convert to C14, and that could the
mhm,
have
mhm,
the fact on contamination. Yet measured
mhm,
neutron production rates appear far too small for for
Mhm.
0.1 to zero point 0.5 PMC in materials like diamonds and petroleum. How do you access the in situ neutron production hypothesis, and what does the or assess the in situ neutron production hypothesis, and what does the actual physics of neutron capture suggest about its implausibility? Now, my understanding on the background radiation, you would probably need thousands of times, because the rate team actually looked into this, then you would actually need thousands of times more than what we actually have to actually make that happen. Because I mean, you're essentially using these things, with fast decay rates, or slow decay rates, and you're trying to replenish something with a relatively fast decay rate, and it just ain't working. Is that
Exactly. So you kind of answer. That's my understanding of it as well. I'm not an expert on, the physics of it all, but that's to me, that's a pretty good summation of what I was going to say. Exactly. It's still not enough to explain the amounts that we see. You can't say there's uranium or something, some other radioactive element nearby all the time and all these things. Now, that leads to an interesting uh, fact, I guess, that's out there. A lot of the dinosaur bones are full of uranium, especially in the Jurassic rocks and in the Morrison Formation across the American West. And so that shows you right there that uranium is very soluble and it finds the most porous openings and fills the holes in the dinosaur bones. I have some dinosaur bones behind me that you can pick up and use a Geiger counter. They're just like clicking off the scale. You can go to Dinosaur Ridge near Denver, Colorado, stick a Geiger counter, which my former Chevron colleague, I think he's passed away now, Norb Seigen, laid down there for my students. And he was clicking off the scale on the bone. He went to the sandstone a foot away and there was no clicks hardly at all. So uranium is very soluble. And that's why it's always moving in and out of the system, which makes dating with uranium very, very difficult because there's groundwater everywhere, as I mentioned, but most geologists don't realize that. Most of them, they don't study groundwater flow and hydrogeology, don't realize how much water is actually flushing through everything all the time. There's no way to isolate a system, which is what they have to do to assume they can get an age date. You have to say it's a closed system, and there's no closed systems. And so uranium particularly, if you're going to flush the uranium away, you're going to leave the lead behind. The lead might be a little bit less soluble. You're going to make it look older than it really is. And so, but the bottom line of your question, though, is there's just not enough uranium everywhere to be this consistent, to consistently contaminate with the same amount. Again, the consistency argues against that as well. That everything's coming back with the same approximate amounts, that whether it's diamonds or oil or coal or dinosaur bones, they're all getting about the same result, which to me argues the consistency of the age of when these were buried during the flood. Everything was buried about the same
Right.
time.
Even critics acknowledge that after roughly 20 half-lives, any original Z14 should be reduced to effectively zero. Coal seams, petroleum reservoirs, and diamonds are all dated within the conventional model to well within that limit. In your view, what does the survival of measurable C14 and these substances suggest about their true age and the assumptions built into the conventional timeline?
It suggests they're young, suggests they're only 4,000, 4,500 years old. That's kind of, even though we get 40,000 for a number, there's way too much to be contamination, way too consistent to be contamination. Again, the C13 that's found along with it, they always measure when you do C14, you always do C13. Those are given numbers that fit within the realm of what you'd expect for plants that were eaten by these animals. And so if the carbon-13 is not contaminated, the carbon-14 is likely not contaminated as well. And again, the consistency across all these different materials, coal, oil, uh, coals, diamonds as well, all these things really show that the earth is young, that these materials were generated just thousands of years ago, not millions, definitely not millions. Because carbon-14, as we talked about, you can't measure anything beyond 20 half-lives, which is a maximum of 80 to 100,000 years old. Anything older than that, there should be zilch there. And they've gone back to try to zero out their systems by thinking, okay, here's some coal from the Permian. It's 200,000 years old or so. Let's look at that. And then they still had carbon-14. And they were like, huh. And so there's nothing that what has carbon in it that they've measured that doesn't show some sort of measurable carbon-14. I don't think there's hardly anything they've ever found that's run out of carbon-14. There's always something in there. So they have to say it's contaminated. It's contaminated by uranium. They throw all these contamination, stories and scenarios at us, but the consistency argues against that because you wouldn't get the same amount of, uranium or thorium or something near every little thing that we test for in the oil and everything. You know, the consistency, again, the carbon-13 consistency, all argues that these are all legitimate ages, or at least legitimate amounts. The ages are generated because they assume today's atmospheric ratio of carbon-14, which I think is different in the past, and that's why the numbers jump up a bit. We're going to look into
Right.
that, I think, here at ICR a little bit as well. That's one
Right.
of the things I want my physicist down the street down the hall down here to look into is why is there a sudden jump from, carbon 14 dates 4,000 years, all of a sudden it jumps up during the ice age to 40, 50,000 years old. And then after that, they kind of give up on it. But yet, why is that? And it has to do with the atmospheric ratio of carbon 14 for whatever reason.
Right.
So, I mean,
Okay,
it's the
Doctor.
consistency to me.
Right. Okay,
Sorry.
Dr. Clarey, taking everything we've covered today, from how oil companies actually operate, to the limits of radiometric dating, to the persistent presence of C14 and supposedly ancient materials, what do you think is the single most important conclusion the public should take away from the real state of the geologic evidence?
That you've been lied to. You've been lied to a lot by the old Earth evolutionary community who has the textbooks, who has the college classes. They have the whole system rigged in their favor. And you've been lied to. You don't need deep time to find oil. You don't need deep time to find coal. You don't need deep time. None of these things are requirements to find the oil. And in fact, they work against it because the oil should have decayed away. And all the evidence you're finding now in these diamonds, in these, C14 samples of dinosaurs, the original tissues we're finding in dinosaurs, original cells and blood vessels, and what looks like red blood cells. They won't quite admit it yet. Osteocytes, cells that make the bone. All these things are still in all these dinosaurs, and they're in animals and critters, even worms, buried down in some of the oldest sedimentary rocks, supposedly 500 million years old, some of the early flood rocks. There's still original proteins. How can that be? How can all this stuff still exist? How can we still have carbon 14 and all these different substances? And it comes down to you've been lied to. The oil industry will not collapse if the world today, if God stepped out and said, by the way, folks, my Bible is true. The flood really did happen 4,500 years ago, like I said. Uh, Everything else you've been saying is wrong. We'd still be able to find oil. We'd be thanking Jesus for providing the oil for us during the flood. So we have these energy resources. It was God's providence to provide the coal and the oil in the destruction and judgment of that first world. He provided all these resources for us in the later world so we could develop and so we could, go to all the different continents. We could kind of, have dominion over the earth, not to destroy it, but to have dominion over it where we can kind of control things. But unfortunately, evil people do a lot of evil things and a lot of pollution, and we've done a lot of bad things as well. But that flood was a judgment for the wickedness of mankind. We see that wickedness seems to be increasing as we go along. But God offers us salvation through Jesus, and we can escape the next
Amen.
judgment by walking through his door he's opening, because I am the door of salvation. Just like the ark was the door. The door of the ark was salvation for Noah and his family members and anybody else that wanted to go. But only 8 people did. But today, Jesus opened up by his death on the cross and his shed of his blood, salvation for all humans. Anybody that wants to walk through that door and say, I believe in Jesus, I repent of my sins, I want to follow Jesus.
Yes, absolutely. All right. Final question. What is your conclusion that you want to leave everyone with concerning things like radiometric dating, C14 oil, coal, diamonds, etc., and the myths about the reliability of radiometric dating? Just basically give some final thoughts, final words. Um,
Mhm.
I know time kind of escaped us here,
It's
but we're fixing to wrap up, and just kind of let people know what your final thoughts are on this matter.
Well, if you want to, well, first of all, if you want to know more, well, there's a lot of creation groups out there, but I think where I work at the ICR.org, ICR for Institute for Creation Research.org is a good place to start if you want to find resources. We have a lot of free articles. You can search our website. We have lots of books, lots of materials, lots of DVDs, lots of digital downloads. We're constantly putting out new stuff. Our YouTube channel, it's free to subscribe to. Lots of information out there that you can get. So a little bit of a shameless plug for where I work, but I think it really is helpful. If you have questions about carbon 14, you want to know more about, what is this guy talking about? Is he crazy or not? You can look into the articles written by my colleagues and other people in the past, others like John Baumgartner, he used to work for us, so we have some of his articles online, all this kind of stuff. If any of this struck a chord with you today, you know, maybe it's a shock to you if you're in oil and gas. So, well, I don't have to believe the rocks are millions of years old and still find oil. No, if you really believe the Bible is true and the Bible's genealogies are accurate, then we, think that that tells us the Earth is 6,000 years old, and the science backs it. Science is confirming a young Earth. All those carbon-14 dates where we get reliable, consistent dates, all the original proteins found in dinosaurs and other animals, all this stuff is telling us the Earth is a lot younger than we thought. And oil can't be millions of years old. Oil doesn't take millions of years old to form. It's just the idea we've been taught this for years and years and years, and it's so hard to get it out of our head. It's almost have to retrain your brain to think, wow, the Earth can be young, and I can still find oil, I can still find coal, I can still find minerals, and none of it really matters when it comes down to whether it's just matter whether it's there or not. And I believe the best way to explain coal and oil and these resources that are still there is that they are young because they can't survive for millions of years. They get eaten away, they decay away. Lightning strikes at burning coal seems up all the time all over the world. There's still be some coal probably deep in the earth. I'm not sure it could last for hundreds of millions of years because it is organic. I'm not sure if, but the oil for sure decays away. We see that. We produce a lot of biodegraded oil today. Most oil is biodegraded to some extent. So the
Right.
idea is the world will not collapse if you now suddenly find out or believed that what God's word says that the earth really is 6,000 years old and there was a flood about 4,500 years ago as a judgment. So and the data, the science supports that. It's just that science is either ignored or just, most of the scientific community just says, oh, it's all contamination. But they don't really explain how it's contaminated. They throw a few things out there like, oh, you have too much uranium in here, but you wouldn't get the consistency that we see in the carbon 14. And I'm sure Dr. Snelling
Right.
talked about the age dating of, rocks in general, lead, uranium, rubidium, strontium, all these different methods. They're
Right.
all based on assumptions that can't be verified. And the rate project showed that you get numbers all over the board. You send a sample of the same rock in for two different methods, you get two different numbers that are dramatically different. And then what do you choose? And so most evolutionary scientists have to choose the number that fits the system that they've already kind of got laid out. If you're too far away from the right answer, then you're obviously your sample is contaminated, even though it probably wasn't. It's just that the system is rigged to fit their old Earth, and so they make the assumptions that nothing got in and out of the system. We can tell exactly how much parent, how much daughter. Even the isochron method is a mixing curve. You don't know where you are in the mixing curve, and so everything's been flushed by groundwater constantly, and I
Yeah.
can't stress that enough.
Me and
That,
Dr.
that makes a
Snelling
lot of
talked
these age
about,
dates wrong.
right.
Mhm.
Me and Dr. Stanley talked about the mixing lines and
Mhm.
false isochrons that can occur and things like
Mhm.
that, and isochron dating. So
He's an
yeah,
expert on
we
that more
discussed
so than
that.
me.
Yeah,
But
he's
but
very good
yeah,
on it.
the general public needs to know that the scientific community is just telling its tall tale in terms of deep time. You can find
Right,
oil. Repeat myself again. You don't. The Earth doesn't have to be old. Actually, it can't be old to actually have all this oil out there. The oil can't be that old. It's it's the science behind it is. I've tried to find why they can say the oil is old, and all the papers that I can find is well. There's not very many. They just kind of go with the story, but they have to argue that it was pasteurized, and then it stayed pasteurized for tens of millions of years, or even hundreds of millions of years. And that's when you study groundwater flow. That's just nonsense. You can't. Nothing's going to sit there for 100 million years and not
right,
be affected by ground bringing in more bacteria. It's just But the problem is we're taught in school millions of years. You're taught basic modeling only works if you have millions of years in there. But it's a matter of how many sediments are piled down there. How deep did it get buried? Do I have a source rock? Do I have with enough organics? And all this is best explained by a recent global flood that affected every continent at the same time. And that's what my research has really shown, a progressive flood. They buried environment after environment. That's why we see a difference in the fossils. Started with just shallow marine areas on every continent, and then more and more and more. You went up to the swampy areas, lowland areas, and then you get to the upland areas. Different animals, different plants lived at all those different levels, but so we see the same exact fossil record pretty much in the same order. on every continent because of the different ecological zones being buried as the water went higher and higher. So I'm sure
Right.
Dr. John Baumgartner talked about his rapid plate movement we think happened during the flood as well.
Yeah,
And again, he's
we had a separate interview
he's
a while back on
yeah,
CPT.
yeah he's ignored by most of the mainstream scientists. They go, well, he's a smart guy. We don't understand why he pushes that. But most of the people don't know what to do with my data. I'm showing six now seven continents of data. The rocks that are still there today, and those rocks, like Jesus said, those rocks are crying out. There was a global flood. Everything's the same layers, same time, same order on every continent. How do you explain that any other way besides a global flood? And the global flood
Right.
explains the oil because it buries organics. It buries them recently, and that's why the oil is still there. Everything about it is screaming young, 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 and yet conventional science is going, well, that can't be. And so they work out their system. They have the majority opinion on their side. Unfortunately, they've kind of duped the scientific community into believing this deep time paradigm. And so they have to make everything fit into that paradigm, no matter how
Right.
silly it might seem. But and we're seeing more and more it's going against science. The real science out there is showing the Earth is young.
It has been great having you on, Dr. Clarey. I appreciate it very much. I know we went a little bit over our time, but hopefully not too much
Okay.
over. Um, but it's been a pleasure. It really has, and very enlightening as well. I'm so glad that we had this discussion, and I can't wait
Mm.
for it to be uploaded on YouTube. And I appreciate everything you do at ICR. I've had several people on ICR so far. I've had Dr. Tompkins on twice, including one recently,
Okay.
to discuss a
Mm.
new paper that came out on the differences between humans and apes. And so we had that discussion, and of course I discussed his
Yeah, he was
original
right all
research a while
along,
back.
wasn't he?
Yeah,
He was right all along. He's been right for
right,
10 years.
right.
And now the evolutionary committee is admitted we're only like 80 some percent like chimps after all. So he was
Yeah,
ignored for many, many years. They're coming to the same conclusion. So again, if you're doing good science like we are here at ICR, I think, our research is showing that, what we're finding is there really is evidence of a global flood. That God created everything just 6,000 years ago. And, but, humans mucked it all up by being too wicked. So God had to judge the world. But that's what's going to happen again. And so, but we can get salvation through Jesus. That's the bottom line.
right. Awesome. Again, thank you. I appreciate it. I will contact the guy that I have the email for and send my address if you want to send that book
Okay.
to me.
Benjamin.
Um, all
All right.
right.
Sounds good. Thank you. I'll be glad to send it to you. Thank you for this
All right.
opportunity.
No problem. Thank you. We appreciate it very much. And God bless.
All right. God bless you. All right. Bye bye.
Bye.